Hello class, today we're on 7.5 System of Equations word problems. So we're working with systems of equations, and systems of equations can actually be written as a matrix. So that's where the similarity comes in from matrices that we're working on. But now we're going to be working on word problems. So the steps for the word problems, the first step is to define the variables and set up the equations. So we're going to have two equations for all of these. Step 2, we need to solve for one variable and plug it into the other function. Very important, it needs to be the other function. So we solve for the variable on one function, or one equation, plug it into the other equation. Step 3, solve for the variable. And then step 4, plug in variable to solve for the other variable, because we'll have two variables here. So let's just get right into this. You are selling donuts and coffee. Each donut costs $1.50 and each coffee costs $1. At the end of the day, you made a total of $77.50 and sold a total of 63 donuts and coffees. How many donuts and how many coffees did you sell? So we need to start off by defining our variables. I'm going to just use x and y. So x, I can say, is the number of donuts, and y is the number of coffees. So we need to figure out how to set this equation up. And so the way I'm looking at it is we can have two statements. We can have one that talks about the total dollar amount that we've made, and then one of the total of number of things that we sold. So we can start off by saying, I know that 150 times the number of donuts, that's the cost of each donut, plus $1 times the number of coffees I sold equals the total of $77.50. I can also say that I know that the number of donuts I sold plus the number of coffees I sold is going to be equal to the number of donuts and coffees I sold total, which is 63. So we just did step 1. We defined our variables and we set up our two equations. Now we need to solve for one variable and plug it into the other function. So this is where you have a choice. You can say, okay, well, I don't know what I want to solve for. I could solve for x or y, and you can do it on either equation. This second equation is looking a little easier for me, so I'm going to solve, it doesn't matter, I'm just going to solve for y for this equation. So if x plus y is equal to 63, and I'm going to solve for y, then I just need to subtract x from both sides. So y is equal to 63 minus x. So now that I've solved for an equation on solved for a variable on one equation, I'm going to plug that into the other equation and solve for my variable. So notice I solved for y, so I'm going to plug this whole thing in for y right here. So I'm going to have 150 x plus 1 times y, which y is 63 minus x, equals 77.50. And so now I need to, step 3, I need to solve for the variable. So let's just solve for the variable here. I have 1.5x plus 1 times 63 is just 63. 1 times negative x is minus x equals 77.50. And we can combine our x's here. 1.5x minus 1x is 0.5x plus 63 equals 77.50. And now we just subtract 63 from both sides. I'm going to go up here. So we get 0.5x is equal to, I think it's 14.5. Let me just double check. I don't want to mess this up here. Yep, equals 14.5. And then divide both sides by 0.5. So x is equal to 29. So that means that 29 donuts were sold. So now that we've solved for the variable, step 4, we need to plug in the variable and solve for the other variable. And this time it doesn't matter which of our two equations we use. These were our two equations. It looks like the bottom one is a lot easier math, so I'm just going to plug it into the bottom one. So x is 29, so I can say 29 plus y is equal to 63. And then subtract 29 from both sides. I get y equals 34. So, how many donuts did we sell? 29. And how many coffees did we sell? 34. Awesome. Let's go on to the next example here. So this one's saying you and a friend go to the corner store to buy chips and soda. You buy 3 bags of chips and 2 sodas, and your bill comes out to $9. Your friend buys 4 bags of chips and 2 sodas, and his bill comes out to $11. How much do the chips cost, and how much do the sodas cost? So what am I looking for here? I'm looking now for the cost of the chips and the cost of the soda. So as opposed to my last one, we're talking about the actual number of things. Now my x is going to be the cost. So x equals the cost of, let's see, I'll just say x is chips, so cost of chips, and y will be the cost of soda. All right, so now we need to set up our two equations. So let's see. The first equation is going to be our purchase. So it's going to be 3 bags of chips, so 3 times the cost of the chips, plus my 2 sodas times the cost of the soda is equal to 9. Then we can say that the other equation is going to be our friend's purchase. So they bought 4 bags of chips plus 2 sodas, and their bill came out to $11. So now that we've set up our equation, we need to solve for one variable and plug that into the other equation. And it doesn't really matter which one you solve for, x or y, and it doesn't really matter what equation you use. Sometimes it'll be easier. Sometimes you'll kind of hit a dead end where the mathematics gets a little tricky. Sometimes one way is much easier than the other. In this case, I'm just going to solve for y using the second equation. So I have 4x plus 2y equals 11. And I'm going to solve for y here. So it means I need to subtract 4x from both sides. So I get 2y is equal to 11 minus 4x, and then divide both sides by 2. So y is equal to 11 divided by 2 is 5.5, and 4 divided by 2 is negative 4 divided by 2 is negative 2x. There we go. So now that I have solved for this, I'm going to plug it into the other equation. Very important. You can't plug it into the same equation. It needs to be the other equation. So I use this equation to solve. Therefore, I'm going to plug it into the first equation. So let's see here. I'm going to say, I'll just do this so we have it kind of in a nice little box here. I'm going to say that 3x, I'm using the first equation here, 3x plus 2y, but I know y is 5.5 minus 2x, equals 9. And then I just need to solve for x here. So 3x plus 2 times 5.5 is 11. 2 times negative 2x is minus 4x, equals 9. Then we can combine our x's, so 3x minus 4x is a negative x, plus 11 equals 9. Subtract 11 from both sides. We get negative x equals negative 2, which means that x is equal to positive 2. Awesome. So now that I have solved for the variable, that was step 3. Step 4 is plug in variable to solve for the other variable. And it doesn't matter which equation we use now. So I'm just going to use the first one, just I don't know why. 3, but I'm going to plug in 2 for x. So 3 times 2 plus 2y equals 9. And now I'm going to solve for my y. So 6 plus 2y equals 9. Subtract 6 from both sides. 2y is equal to 3. And divide both sides by 2. So y is equal to 1.5, or 150 since we're talking about cost. So the cost of the chips was $2 and the cost of soda was $1.50. Awesome. I have one more example for us. So it says you are selling tickets to a musical at the school. On the first day of sales, you sell 12 adult tickets and 16 child tickets and make a total of $164. On the second day of sales, you sell 10 adult tickets and 14 child tickets and make a total of $140. How much do the adult tickets cost and how much do the child tickets cost? So, we're talking about cost again, so X can be the cost of adult ticket and Y will be the cost of child ticket. Okay, so now we need to set up our two equations. So the first equation is going to reference the first day of sales, and the second equation is going to reference the second day of sales. So the first day of sales, we sold 12 adult tickets at the cost of whatever it is, plus 16 times the cost of whatever each ticket that is, and we made a total of $164. Our second equation is the second day. So on the second day, we sold 10 adult tickets at the X cost, plus, 14 child tickets at Y cost, and that cost $140. So now that we have our variables defined and our function set up, we just need to now solve for one variable and plug it into the other function. This time, let's just use the first one. We haven't done that yet. So I'm going to take the first equation and let's see. I'm going to solve for y. So I'm going to subtract 12x from both sides, and I could have just as easily solved for x as well. 16y equals 164 minus 12x. And then divide both sides by 16. So 164 divided by 16 is 10.25. So y equals 10.25. That was just the 164 divided by 16. Minus 12 divided by 16, which is 0.75x. Awesome. Now that we solved for the variable, let's plug that variable into the other equation. And that's where it's important to plug it into the other one. So now let's plug it into the second one. So we're going to have 10x plus 14 times y. But y is now this business. So 10.25 minus 0.75x equals 140. I'll just box these since that's what I've been doing. Okay, so we have 10x, 14 times 10.25 is positive 143.5, and then 14 times 0.75, or negative 0.75x is negative 10.5x equals 140. Now we can combine our x's, so 10x minus 10.5x is negative 0.5x plus 143.5 equals 140. We can subtract 143.5 from both sides. And we get negative 0.5x is equal to negative 3.5, which means that so now we're not done solving. Sorry about that. Negative 0.5x equals negative 3.5. Now we can divide both sides by negative 0.5. And x is equal to 7. Awesome. So now that I have my x value, let's plug it into either equation and find our y value. I'm just going to use the first equation. So 12 times 7 plus 16y is equal to 164. And then 12 times 7 is 84, plus 16y equals 164. Subtract 84 from both sides. 16y is equal to 80. And then 80 divided by 16, well, let's see, 16y equals 80. Divide both sides by 16, so 80 divided by 16 is 5, so y is equal to 5. So the cost of the adult ticket was $7, and the cost of the child ticket was $5. So here's my advice to y'all. If you're ever doing one of these problems and you kind of come up to a dead end or the math gets too tricky, try solving for a different variable, or try using a different equation to solve for it. That is my advice, because sometimes you can solve for things and the math just gets really ugly, and sometimes going a different route, it's not so ugly. So if you do find yourself in that situation where the math just gets really ugly, just try solving for a different variable or use a different function. So that's all I have for you today. I hope this helped. Have a good day, everybody. Bye.